All right, let's do some bending here. Let's see how this new stuff performs. Okay, so here's what we're going to talk about. This is a little bit different video. This is a video about me bending hardlines for a custom PC that I was working on. And this PC ended up becoming my actual home PC with, full-on liquid cooling for the CPU, not the GPU, just the CPU. And I just kind of wanted to go over, like, some of the stuff and steps that I go through, because I do get a lot of questions about this when I'm actually bending this live on stream and stuff. So I figured, why not? One of the first things you see me using is this stone. It's a silicone insert that goes inside the actual hard lines that you're going to bend. What you do is you put a little water, a little soap on this, and you slide it in. So that way, once you heat up the actual acrylic or PETG or whatever you happen to be bending, as you make that radius, the actual inside of the tube itself isn't sticking to this, and it's maintaining its inner diameter. Because if you don't, what you end up with is a little guy like that, where it pinches itself, because instead of just sliding along the inside of the tube, it's gripping and trying to separate itself and pull itself apart. So as you can see, as you're watching through this video, I use this stuff pretty heavily, and I do some bends. I do using an actual 90-degree tool that you can get from like Alpha Cool or Mod My Mod. Other times I will do a 90-degree with this, and then I'll manually go and update the bends. So that's kind of the actual process I go through with these. So what you see me doing is I'm doing a lot of measuring. Like you saw me, I had rulers out. What I'm trying to do is I'm trying to figure out the lengths of my actual runs before I actually go in and actually take the tubing, get it hot, get it bent, and then find out it's not exactly correct. So there's two ways that I do this. First thing I do is I have some rulers that I just get general dimensions, and I'll make a note of those general dimensions so that I know where everything is going to go. And then secondarily, what I do is I have a bunch of spare fittings, which you're seeing me use. It's up that way. You're seeing me use now. And what these fittings allow me to do is I have spare tubing just laying around that's dead tubing. I will take these fittings, I will cut tubing to fit in the fittings, and then I'll figure out exactly how I want the runs to look. So instead of guessing, what I'm doing is I'm saying, okay, this is exactly where this run needs to go. This is how this run needs to look. Like for what I'm doing now, my main thing is clearing the GPU, because I didn't know what GPU I was going to be using with this. I didn't know if I was going to be using a AMD card or an NVIDIA card. So regardless, I wanted to be able to make sure I cleared it. The one thing I knew I wasn't going to be doing is I was not going to be using a 4090. If I was using a 4090, I would have had to relocate the pump because it physically would not have fit. This case is a Lian 011 Dynamic Evo, and the 4090 on this comes up to the second fitting that you see on the right side. So it's actually the one that's closest to me, like right over here, that there's nothing in. I would have had to use that, which is not it's not an out in that's connected to the pump. It's like a drain that you can use as a secondary in. So as you can see, I'm going through, I'm using different types of tubing I have laying around. And as you can see, I'm making adjustments. I'm going up to the radiator, trying to figure out exactly where everything needs to line up. And then once I'm done with this, because I'm not exactly like concerned with the specifics of where everything is, or excuse me, I'm not concerned with everything being watertight. I'm only concerned about the overall shape of the hard lines. So I guess let's talk about a couple things. So as you can see, like we'll pause this. well, you can kind of see where I'm at with this. I am I have my overall shape, and you'll see what it looks like in the end. I have my overall shape, and one of the things that I need to do is you can see the line that's coming off of the right here. So this guy here is too long. So one of the things I need to do is actually cut that. So what I use to cut it, I have 3 different tools I use to do my cutting and stuff. I have a simple razor blade, like a pipe cutter that I run around for like certain harder materials that'll snap cleanly. I have a Dremel that I use to cut, and then I also have just a simple hacksaw. And then after I make the cut, I have 2 tools that I use to make sure that the ends of the fittings are nice and clean so they don't tear the end, the actual O-rings and stuff that are inside. So this is like a deburring tool. You literally take your pipe in there. This does the inside, flip it over. It's got a different set of blades on it. And then you do the outside. Just literally just like that. Cleans it up nicely. If I end up with an edge that is, say, cut at a severe angle, like that, so you no longer have, like if this is square and that's what the end looks like, I have just a simple sanding, I don't want to call it a sanding wheel. It's a belt sander. It's like a table mount. It's like a table mount belt sander that I can go and put on. It has a piece of marble under it to keep it nice and stable. And then you sand down until it's perfectly square. And then you're good to go ahead and reuse this tool again to clean it up. So let's pick this back up. So this is the next day. I came in. I'm like, okay, here's the runs that I want to make. Let me see what adjustments I need to make after doing the initial. I cut different lengths of the actual spare tubing that I have, and you can see I'm just trying to get the 90s and stuff right. As far as like heating stuff up, I actually like a heat gun that I can set on my table. I use a simple DeWalt thing, has a temperature adjustment on the back and 2 speeds for the fan. And then I just set it on the table and I move the pipe over it for when I'm doing individual bends. But one of the big things that I don't hear people talk enough about when you're doing a bend, and this is actually pretty important. Let's say you wanted to put a bend. I'll make a mark that you can see. If you wanted to do a bend like a 90-degree right there, so from there to there, you need to make sure that you are not heating up just this area. Because if you heat up just this area, what's going to happen is when you go to do the bend, you're going to get a kink that forms right there. And that kink will lead to what you're seeing right here, which is not going to focus on the camera, but that right there, which that's bubbles from it stretching. So if you wanted to heat this up and you wanted to do a bend in that area, you need to heat the pipe pretty consistently all the way like this. And I'm not saying heat it up so that it's flexible, but you want to heat it up so at least it has some temperature in it so that the center is more malleable. So if this is where I have my heat gun right here, what I'll do is I will move across, hold, move, hold, move, hold, basically go back and forth until while I'm rotating it, because you need to rotate it the whole time. You're not just going to hold it one direction, because you need to get the actual whole tube nice and warm. What I'll do is I'll keep holding it and rotating it until I can let go of one side of this and it starts to sag on its own. And then at that point I know I'm getting close, and then I'll just focus on the spot. Like I'll start making smaller motions, and then I know I'm ready to either take the tube, put it into something like this where I can make my, actually it would actually be this side, where I can make my radius whichever way I want to go, or I can make my own like dimension that I end up wanting to make with it. So one of the other tools that you don't really see me do here, you'll see me do it a little bit later. I use the Vis-a-Vis wet erase markers on these. Some people say they stain. I have never had them stain, as long as once you know where you're, like where you want to mark, where you are going to start your bend, where we take this and we can see I want to take this black line that I put on here, and I want to lower that black line for the inside of my radius down to, which one am I doing this on the right one? Yeah, I'm doing it on the right one. So I want to line it up with right there. So just get it in there like that. Let me just let you switch it over so you guys can see it. So as I lower it down, you can see that's where I know I want my 90-degree bend to start. And then I'll basically just hold it over until that line meets this radius. So one of the big things is you can't go too, you can make really tight bends with these. But if you make too tight of bend, you're going to end up with something like this, or you're going to end up with a bend that physically wants to kink because it's so tight. So when you're looking at this tool, the radius that this gives you, you can just take, like this is a simple trick. You want to see how many millimeters your radius actually is. You set it at the start, and then you just roll it around the edge. So this makes a 2-inch radius bend. All right, back to the video. Kind of walk through some of the other stuff that I'm doing here. So this is me walking back to my back table, making small adjustments to the piping, just so I can get like as close to that 90-degree that I can get, because I want it to be nice and clean and level. In the end, I end up having to move the pump up slightly to clear some other stuff, so it ends up making another adjustment. But you can see that's pretty close to level. If you really want to get super detailed with this, you do it once you actually get to when you're doing your actual bends, and not when you're doing your not when you're doing measurements like this, because getting close is fine. Yeah. So I'm just going through, making small changes, making small adjustments. And then once I'm pretty happy with everything that I have, just get it in place, and then we'll move on to the next one. So one of the other things that I guess I should mention while we're going through this, different materials become malleable at different temperatures. So whatever like material you end up deciding to make this with, make these bends with, or make your water loop with, you really need to be careful, because some of these you put a little bit too much temperature in them, they become hyper porous, and the water ends up coming out, and you're not sure where it comes up, and it's literally like weeping out of the tubing. So you just got to be careful and make sure you're aware of what materials you have and what the materials are capable of. So you can see after some minor adjustments, I get very close to what my final product ends up being with this. Just making a bunch of small adjustments. I actually go up front. I keep a bunch of 90-degree fittings specifically for this, just so I can always kind of follow what is going on here. And I can always make minor adjustments here and there, and I always have a fitting that'll work for me. So, and what you saw me do there is I was actually measuring the distance between the actual pipes from the in on my water block to the in on my radiator. So right there, you can see I'm measuring the distance from the top of the case, which I know is a straight line, to the tubing, and then I'll measure the tubing between them to make sure that it's actively level all the way across. So after I have this all figured out, at this point is when I start actually bending my lines. And see, after, this is the big thing about doing this, is after I have this set up the way that I know that I want it, I can now take this off and basically set up the 90s exactly which way they need to go. I can lay it on a table, and then it gives me a template to actually know where I need to make my bends. So here, let me pause this real quick. And you'll see me right there. And I wish I could do a little bit more granular control than that. Right there. So what I'm doing is I'm checking to make sure, first off, that the tubing that I have will be long enough to actually make this bend. And then secondarily, I am going to take my vis-a-vis and make some small marks on the tube so I know where I need to make these bends. And then I heat it up, make sure I'm heating up a large area of it. And one of the things you see me doing down here at the bottom, I like leaving the tube in here so that I'm not holding a hot tube and I can keep my hand away, and I can constantly and very easily spin this with little to no friction. Whereas if in my hands I'm having to do this and hoping I'm holding it straight, this way here, my whole area that I end up wanting to heat up can be kept like relatively straight no matter what. I heat it up, I wait for it to get close to what I want, and you can see I got my first bend done. And then I just make sure I'm getting my bends where I need to, and I'm making sure that they're getting as close to that 90 degree as I can. And one of the things that like I ended up having to do a couple times with this is the bend that's closest, that's all the way on the left side of the screen right now, isn't tight enough. And you can really see, so you can see it right now, right here, how much of a difference there is between this and this. You're never going to be able to get a straight 90 on something like this. So you want to get as close to that as you can. And once you do get it, once you have your general shape, you can make small adjustments here and there. And with those with those small adjustments, you get closer and closer. Yeah, see, this is something like, this is not a 90. It's gone past the 90. This is something that I can heat this up. I can re-put the silicone, the whatever this stuff is actually called, the silicone, back into it. There you go. And then heat it up and then expand that a little bit. But as far as like moving the bend, it's not really like a thing you can do, because once it's bent, like, let me see if I can show this on one of these cameras that I have. Yeah, and this highlights what I'm talking about right here. All right, so this is really, really hard to see on camera, but right here, you can see where the tube is straight, and then it has this little upward motion right here, and then it goes back down. I had a bend in this tube originally, and I tried to straighten it back out, and I failed. So after that, basically, you get one shot, maybe two, trying to make these bends. Once you fail making these bends, grab another piece, start over. So, I mean, you can kind of see it, like right here. You see how this isn't straight? So it's like there's a kink here. Like that kink that you're seeing that's ever so like it's a step, that comes from me bending this tube and then trying to straighten this tube back out and it not working. Because like the way this stuff is designed is it's extruded through a through an extrusion press. The significance of that is it's all made in a single solid tube. Like it starts off as pellets, gets heated up into an actual like almost like a resin, and then as it cools, it's extruded through a press that makes it exactly this size, but it's an infinite length, and then at whatever the actual dimensions are that the company that they're making it for is asked for. Let's say this is 3 foot lengths. Every meter, it's got an arm that'll just sit there and spin and then cut it. And then you end up with these that get put into boxes. So because the entire tube is heated at the same temperature and then it cools at the same temperature, they can be super malleable at the factory, and like mistakes that they make there can easily be corrected. Whereas here, once you're heating up a small portion of the tube and trying to correct that, it becomes nearly impossible. So in theory, what you're saying, yeah, you could do that. You could do up your tubing first and then move the stuff around, but a lot of this stuff has very set positions. This is valuable, what I'm about to say. Like, for instance, there's only one... And just for context, what I'm about to say applies only to what case you are using. So, if you are using a different case than what I'm using, stuff goes in different places. Some cases have distribution blocks that have pumps built into them. So like the entire back panel where you see where I have this pump sitting right here, like that entire thing is acrylic and it has the pump embedded into it and the hard lines are going into it, and it takes up a lot less room. It gives you a lot more freedom. And then you have other situations where you'll have a separate reservoir, a separate pump, whereas this is a combo reservoir and pump. So once you have your equipment that you're going to put in there, you need to plan it all out before you actually start doing any bending. And that's kind of the point I'm trying to make here. I just don't think I say it very well. One place that this can go. So doing up that is a lot more difficult. So you can see at this point, now it's just making small adjustments and cuts, and then literally doing small steps to get the hard lines where I want them. Because like I can tell you right now, if I remember right, I remake this portion that's sitting coming out of the CPU block, because I don't like that angle. But when you're making adjustments, let's say I know that I need to take off a full inch off of this. I will start by taking off half an inch, like smoothing it out, putting it in there, seeing how close I am, then grinding off a little bit more, putting it back in, and then seeing, like, you never want to just, if you know you need to take a full inch off on this, here, let me go to this view. If I know I need to take a full inch off, I'm not just going to go right down to that inch and assume that it's going to be exactly what I needed to get off of there. So what I'll do is I'll go maybe half an inch and then check it, and then grind it down a little bit and check it, and then grind it down a little bit and check it. You never want to assume that the measurements that you can't see, like how far this pipe is going to sit inside that fitting, is going to be exact from fitting to fitting, because different manufacturers use different tolerances, and then they also use like different thicknesses of the O-rings that are inside of the fittings. So I always like just making small adjustments as I'm going along, instead of assuming that I can make one cut and call it. So there's obviously different types of tubing that you can put in there. There is PETG, there's acrylic, I'm trying to remember, there's another one, there's PETG, acrylic. Really, I think you can also do copper. You can do, like, if you really want to get fancy, you can do glass. If it's made in a tube, You can basically put it in a computer. So as you can see, I marked up my lines where I want to heat them up, where I want to get them bent, and I start getting them into the shape. And you can see I'm moving it around, I'm moving it back and forth, not heating up one place specifically. And you can see right there, that was actually this tube. I heated this thing up to the point where it got bubbles in it, and that was it. That whole tube was done. And you'll see me, I'm constantly, as I'm heating it up, I'm putting it next to the actual fittings I made, or the actual hard line that I made with the fittings, just so I can always constantly adjust where I'm making my bends and making sure that my bends are going to be correct. Because the last thing I want to do is, and I've done this before, I will heat up a spot. I'm like, all right, good to make my bend. I'll make my bend. Let's say this is the bend that I wanted to make. My next bend needs to come towards my face. What I'll do is I'll set it down and then I will bend it away from, like, so that way instead of bending down, I bend up. So I'm always checking to make sure that I'm A, bending in the right direction, B, bending this in such a way that it's going to conform to the shape that I'm trying to make here. And as always, you can see at the top, I keep some water and some soap so that I can always move this in and out easily, and that it will never get stuck to the inside, so that when I make a bend, you again end up stretching the tube instead of sliding the tube. So another question that I get on a regular basis: where do I get my stuff? I either buy directly from Alpha Cool. EK makes good stuff that I've purchased in the past. And then the other place that I get a majority of my stuff is from a website called Mod My Mods. They have just about everything that you would ever possibly need. So in here you can see me adjusting the water pump just up slightly, because that is it's easier to adjust the physical location of the pump rather than adjusting this tube to make a small little change. So, and yeah, that's basically it. So some of the other things to think about after the fact is what kind of liquid you're going to use into it. What kind of liquid you're going to put into it. And I like using, if you're doing a themed build, you can get different color dyes that go in either distilled water, or you can get the cooling liquids that are actually designed with a color already in them. And the thing with those are they are more efficient. They can dissipate heat a lot better. They can carry the heat. They're a thermal conductor better. And a lot of times they'll have like that stuff that I just had up on the stream. Let me go back to that real quick. That is it has like an opalescent material in it that doesn't damage electronic components or the pump. And basically what it does is it constantly, even when the system is turned off, it continues its motion. So it gives you this nice, like, almost think of it like Jupiter look to it. It's really cool. The problem with this is it's only good for a few months, and then you absolutely have to change it. Whereas if you use, like I do chilled water. I use chilled water. I use distilled water with an additive in it that prevents fungal growth. Then I will change my fluid once a year, do a full flush on it, and like at that point I can make any adjustments I need to with the loop. But at the first sign of any kind of material growing in your water loop, you want to pull everything, clean everything thoroughly, and then start over. Another thing you can do is you can get a piece of pure silver, like just a little small, like think of it like a bead of pure silver. Like when I say pure silver, I mean like actually like verified pure silver. You can get something like that's like a ball like this of pure silver. I mean, that's really hard to see, but you can see it down in there. It's just a ball of pure silver. Drop it into your loop, and that'll prevent all fungal growth in your entire loop, basically infinitely, as long as you're using distilled water. So those are some options for your stuff inside. The other thing to worry about is making sure that you're actually putting everything in the correct order. So the things that do not have a like an actual order associated with them. So the pump has 2 ins and like 6 outs. This specific one that I'm using. But this is the only one that's driven by the actual pump. So as long as I'm below this line, this is the out. These are all additional. This one here specifically does, like, how do I explain this? There is a little grate at the bottom of this pump. As long as you are below that grate, there is pressure going out of this whole system. This water, the actual water block that it's on the CPU, the right side of it is always in, the left side is always out. And the easiest way to tell that is check the manual. But if you look at where this logo is for right left, this logo that's on the bottom of it, the in pump will always be on the right side of this logo. The out pump will always be on the left side. The radiators, bidirectional, doesn't matter. But as far as the in on the top of this, you can use either of them. I just like using this one because it creates less turbulence because of where this pipe is. So, and then you can see lastly, I work on making the actual bend. So the path that my loop takes is from the pump we go into the block, out of the block, and then we go up to the radiator, goes through the radiator all the way up, back and forth, and then down, and then back and out the rear near the back of the case, and then it goes into the top of the actual reservoir. So this is me just doing some pressure testing. I fill, empty, which I guess is another best practice. You always want to be filling and emptying the reservoir before you sit and let it run for an extended period of time. I recommend filling and emptying it probably 5 times. That way you get as much material that could be in there, because you don't know what's necessarily in there. There could be small pieces of metal. There could be pieces of plastic from when you were cutting and bending the tubes. There could be just like gunk from oil and stuff from when they were lubing things at the factory. You never know. So you just run clean water through it as often as you can. And then finally, your final step when you go to your actual fill is you're going to put your distilled water in there with your chemical additive, and then you're going to run that for what you're seeing me do now. You're going to run that for an hour to leak test it. While nothing else on the board has power, I'm only powering this loop at this point. And then after that, empty, fill, and you are good to go. So after a full hour of pressure testing this thing, just to make sure we don't have any leaks, I say, hey, we are good to go on this. And what I do is I actually take the time and I make a little drain, which you can see right there. So I make a drain that screws onto the front out of this. So when I turn it on, the water will flow through the path of least resistance. It'll come out, instead of going into the CPU block, it'll come out here. And this kind of illustrates why I say after you've run it for an hour, you empty it out. You can see I now have this hooked up. The water is getting forced out here. And when we look at the water, I can do this. And we're getting... And right about now, I can do this. There. So this was all like inside of the loop when I got it done. All these little black spots you see, this, whatever this is. And what all this is again, it's detritus that ends up inside of there from when you're working on it. Or if, like, at some point when you were putting this all together, you tore one of the O-rings that's inside, that's a piece of the O-ring. So yeah, after that, that's it. And if you ever aren't sure, you can always come. You can ask me. Look on the internet. There's a lot of guides out there. Jay's 2 Cents has a great guide on doing water hardline cooling. To make all of this much easier, another option would be using Softline for everything. That would greatly reduce the amount of work that would go into this. I don't think it looks quite as good. The other thing that you could, so just some like nice to haves, you can buy a simple pressure tester, like this leak test thing. It's just a little bike pump that you pump up. It's got a little gauge on it, and as long as it maintains its air pressure, it'll definitely be watertight. Lastly, if you put something together, as long as you like it, that's all that matters. And if someone comes to you and says, hey, your water cooling setup is stupid or crap, not only does it not matter, but ask them to see theirs. Because if they're comparing against someone that does it professionally for a living and you don't do it professionally for a living, as long as you enjoy what you have in your computer that you are using, that is absolutely all that matters. So thank you for watching this little video. I'm going to post some photos and some videos of what this looks like when it's all done. And yeah, thank you. And if you like this video, make sure you hit that like button. If you want to see more videos like this, make sure you hit the subscribe button and leave some comments down below. And I stream daily on Twitch from 9 a.m. to about 5 p.m. Eastern Standard Time. So come hang out and maybe learn a thing or two.